In this session, we will discuss conservation of momentum using man and cart problems, or it is simply the application of conservation of momentum using man and cart problem. See, we have two men A and B, each of mass m, are standing on a cart of mass capital M, which in turn is standing on a frictionless surface. The man jumps on the same side in quick succession with B following A. Find the velocity of the cart after B jumps off it, given the man jumps with velocity u relative to the cart. So let's draw the cart first. This is the ground. This is the cart. On this cart, two men A and B are standing. Both of them have same mass m and m. The cart is C. The mass is capital M. Now it is given that they jumps off the cart with velocity u relative to the cart. See, in this question, the momentum, that is P, of the system, that is, in the first case it is A plus B plus cart C when A jumps off it, is conserved. This is when A jumps off the cart. Also P is conserved, that is, the momentum is conserved when B jumps off the cart. The reason is very obvious, because there is no horizontal force, external force acting on the system. When is momentum conserved? Momentum is conserved only when F external is 0. So this is what we are aware of. So let's decide. First case is when A jumps off the cart. So the system here is A plus B plus the cart C. What is the initial momentum of the system? Pi is 2m plus capital M into 0, because initially the system was at rest. What is the final momentum of the system? We are conserving momentum with respect to the ground frame. So Pf is mass of A multiplied by velocity of A with respect to ground plus mass of B plus mass of C, that is the cart, multiplied by velocity of cart with respect to ground. We are denoting it as VCG. हम इसको किससे डिनोट कर रहे हैं? VCG से. ठीक है. A के जंप करने के बाद सिस्टम को किसका बच गया है? सिर्फ B और कार्ट साथ साथ मूव करेंगे. किस वेलोसिटी से मूव करेंगे? We are calling that velocity as VCG. Now, since momentum is conserved, therefore we have Pi is equal to Pf. Let's see how we can tackle it. Pi, which is equal to Pf, and this is given as 0, is equal to mass of man, velocity of A with respect to ground, plus mass of B plus mass of cart, velocity of cart with respect to ground. This is the first expression. We want to find what is the velocity of the cart when man jumps off the ground. So we want to find what is VCG और हमको VAG भी निकालना है. दोनों चीजें निकालनी है. ठीक है. दो इक्वेशंस हैं, दो अननोन है. दिस इज ऑल्सो एन अननोन एंड दिस इज ऑल्सो एन अननोन. पर हमको यहाँ पे मालूम है कि वेलोसिटी ऑफ ए विथ रिस्पेक्ट टू कार्ट क्या है. ये दिया हुआ है u वेक्टर. दिस इज रिलेटिव वेलोसिटी ऑफ ए विथ रिस्पेक्ट टू कार्ट. ये आएगा वेलोसिटी ऑफ ए विथ रिस्पेक्ट टू ग्राउंड माइनस velocity of cart with respect to ground. So this is the second equation which we have. Solving these two equations, we get velocity of A with respect to ground will be plus m u vector upon m plus capital M. So A moves along the same direction in which the relative velocity was, right? Also we get velocity of cart with respect to ground after A jumps off it is minus mu vector upon m plus capital M. So this is the velocity with which now the cart B plus C is moving. The cart is moving along with B with this velocity, which is given to us as VCG, right? Now let's draw the cart again. Now the system is, now A is out of the system, right? On this cart, the person left is B and the system and the cart is C. Again we have that. These two are moving along this direction with velocity VCG, right? Now, so what is the initial momentum of this system now? Let's write it as The initial momentum of this system is Pi, which is equal to, we are considering the system is B plus cart now. This is very important. ये बहुत ज़रूरी होता है जब हम सिस्टम चूज करने वाले रहते हैं और जब हमको मोमेंटम कंजर्वेशन देखना होता है. यहाँ पे ये आएगा मास ऑफ मैन B प्लस मास ऑफ कार्ट M इंटू वेलोसिटी ऑफ C विथ रिस्पेक्ट टू ग्राउंड. ये इसका इनिशियल मोमेंटम है. फाइनल मोमेंटम क्या होगा इस सिस्टम का? मास ऑफ B इंटू वेलोसिटी ऑफ B विथ रिस्पेक्ट टू ग्राउंड प्लस मास ऑफ कार्ट इंटू वेलोसिटी, इसको V डैश हम कर लेते हैं, V डैश CG. व्हाट इज दिस V डैश? V डैश वो वेलोसिटी है जिससे ये सिस्टम, जब ये B बाहर चला आएगा तो कार्ट जिस वेलोसिटी से अब जो मूव करेगा दैट इज वेलोसिटी V डैश CG. V dash G is the velocity of the cart after man B jumps off it. Okay? फिर से हम मोमेंटम कंजर्व कर सकते हैं. यहाँ पे मोमेंटम कंजर्व करेंगे तो क्या मिलेगा हमको? m प्लस m टाइम्स VCG इज इक्वल टू m इंटू VBG प्लस कैपिटल M इंटू V डैश CG. फिर से हमको ये दोनों वैल्यूज नहीं मालूम है, VBG और V डैश CG, पर हमको अभी यहाँ पे फिर पता है कि वेलोसिटी ऑफ B विथ रिस्पेक्ट टू कार्ट, किस वेलोसिटी से कूदा था ये, इसको VC डैश लिख लेते हैं. किस वेलोसिटी से ये जंप किया था? U वेलोसिटी से. और इसकी वैल्यू आएगी VBG माइनस V डैश CG. So now again we have two equations. This is equation 3 and this is equation 4. Now solving these two equations, we will get it as, substituting the value of VBG as U plus V dash CG, we have, it is M plus M VCG is equal to M into U vector plus M plus M times V dash CG. So we get V dash CG as MU vector, it is VCG minus MU vector upon M plus M. This is the velocity of the cart after B jumps off it, right? Substituting the value of VCG also, it was minus MU vector upon, here it was 2M and 2M, right? When we solve it, we will get this. It was 2M plus capital M minus MU vector upon M plus M. So this is the final value of it. Please remember, it is the total mass of the system which is in the denominator. So in the first case the system was 2M plus M, in the second case the system was M plus M.